So it's important to emphasize and for us to understand what happens if we didn't have a clear method, or what happens if we didn't have a destructor. So, you know, I've said before, for every new there has to be a corresponding delete. And in previous examples, it's been pretty simple. We would do a couple of news and then we would just turn right around and just delete it. Well, here it's not so clear. You know, someone could use the read method to create a list of integers, and we have no idea how long that object might persist, how long they may use that list of integers, or when that list of integers might get destructed. So if this is, you know, a main program or something, this could run for a very long time. So what I want to just hit home, and again, you know, one of the things you could do is comment out clear and run valgrind, create a list of integers and run valgrind and see what happens. But let's say, for example, that, you know, LOI here has a list of these nodes. And, you know, this object, this is the state of the object when we reach the end of this block. Well, what happens is the primitive types are deallocated by the default implementation of the destructor. So when we were talking about the time class, I was talking about this default implementation of the constructor or the destructor, and how it would deallocate the basic types. Well, the basic type that it's going to deallocate here is the head pointer. What it's not going to do is it's not going to deallocate all of the nodes that we dynamically allocated. And we have to rely on the destructor, or in this case, rely on the fact that the destructor calls the clear method to traverse this list, deallocate these nodes. After clear executes, then we're in this situation where we have no elements of the linked list, and now when we deallocate head pointer, we will have recovered or freed all of the memory that this list was using.